Hey guys, welcome back to the Pepcoding. So in this video, we are going to discuss our next question, that is quadruplet sum 2. So basically, in this question, we have given 4 arrays. Uh, Okay, so this is the statement. So in this question, we have given 4 arrays, A1, A2, A3, A4, all of the integers array, and size of that array as the same length, that is n length array. And we need to find a count of all unique quadruplets A, B, C, D such that A1 of A, A2 of B, A2 of C and A4 of D equals to 0. Let's say this is a K. This is our target K. Okay, target K. Now, what is the quadruplets here? So these are the indexes. Let's say that this is the indexes A, B, C and D. So A represents the array 1 of A, array 1's index. This A is the array 1's index. So A1 of A gives us some element. B value, B index represent array 2. So AB of B gives us element 2. This C represent array 3. So array 3 of C gives us element 3, and D represent the array 4's index. So A4 of D gives us element number 4. Okay, so when we are adding these elements, that sum should be equals to 0 or K. That sum will be that sum should be equals to our target, that means K, that is 0 for this question. Now, how to solve this question? For solving this question, let's say we have given a 4 arrays A, B, C and D. We are going to convert these 4 arrays into 2 arrays. That means A, B, okay, and C, D. Okay, okay. So array A contains some elements, that means A, B, C, D, and array B contains also some 4 elements, same length array. So E, F, G, H. So we are going to create a combination by using these arrays. So let's say AB, this is a 2D array. So A is going with E, A is going with F, A is going with G, and AH. B is also E, BF, BG, BH, CE, CF, CG, CH, and DE, DF, DG, and DH. So now we are created all the possible combinations by using these 2 arrays. So the rows are n and the columns are also n. So the possible combinations that we are created here, that is O of n square. Now let's assume that we are also created for CD also. Now this problem is reduced for the 2D array, not of previously this problem is for 4D array. Sorry, 4 array, 1D array, and now this problem is reduced to the 2D arrays. Now, so this problem statement is let's say this 2D array. Now we need to find a value into AB array. Let's say this is the point we are finding the element, that means value. So we are taking this value firstly, and we need to find this value into another array as a k minus element. This is element. Okay, this is the element, and we need to find this element into another array, that means CD array, as a k minus element. Okay, k minus element. So how we can write this? So AB of I plus CD of J should be equals to K. Okay, this should be equals to K. So also we can write this as a AB of I equals to K minus CD of J. Okay, so this is the this gives us, this expression gives us some value to us, and we are going to find this value into AB. Okay, AB, if we are finding that value and their sum is equals to our K, then we got our one quadruplet sum. Now for solving this, let's say this is the two D arrays, two 2D arrays. We are going to solve. We are going to find that quadruplet sums into two 2D arrays. So let's say our CD array is this. Okay, this contains elements at these positions. Okay, and we are going to find this value A, and that value, that element is equal to this element. Okay, and we have n square information, and we are going to search that element into another n square information. So we have n square information, and we are going to find that into another n square information. So our search takes n square time. Search takes n square, search also takes n square time. So the time complexity when we are going to use the 2D arrays is n raised to 4. Okay, now we need to reduce the time complexity. So how to reduce the time complexity? So now we are going to use a map. That map contains the combination versus how many times the combination occurs. The combinations occurs. Okay, how many times the combination appeared when we are finding that. Now the problem is reduced. Let's say map, when we are finding any combination, any key values into map, then it takes O of one search. O of one search. So when we are searching any element into map, then it takes O of one time, and we are going to search n square combinations into our map. Then the time complexity is going to reduce, sorry, n raised to, that means n square n raised to 2. So our time complexity reduced by n raised to 4 to 2, n raised to 2. Okay, so this is our approach to solve this question. So let's code this. Let's start with the code. Now firstly we need to use, we are going to use here unordered map. So unordered map of int 8. Okay, this is a map. Now firstly, let me do a full screen first, increasing the font size. Okay, firstly we are storing the combinations into our map. It means we are going to use the array A and B for that. So we are traversing over int element 1 from array A and element 2 from array B. Okay, and we are going to add that combination E1 plus E2 into our map, and if that occurred for the second time, then we are going to increase the count of that combination. Now we are going to traverse over the element 3 on C. We are going to traverse over C and D loop, C and D array. That means this is element 4 on D, and at this point we need a count. So initializing the count here, count is 0 for the first time, and if count plus equals to, if we find the value, then our count is going to increase. If we can't find that value, then our count will be 0. Now at this point we are going to find that into our map, find that as a E3 plus E4 minus that element. Okay, we are going to find that minus that element dot, if this is not equals to end, then we got that value, we got that indexes, that is that sum, all that sums equals to our k. So we are updating this as a minus e3 plus e4. Okay, and if we can't find that, we are going to add the 0 here, and after that returning count from this point. Okay, count from this point. So this is full code. In the first part, this part, we are going to create all the possible combinations of array A and array B, and we are storing that into our map. Okay, unordered map. After that, in this, we are traversing over our C and D array. We are making a combination of that. If that value minus our target, if we are finding that into our map, then we are saying that we got that combination, and if it is our equals to our k, then increasing our count here, and we are returning from this. Now let's try to run this code. So we got some error here. Unordered map telling map, unordered map. Let's try to run it again. Unordered map was not declared in the scope. Okay, so here we need to include that. Let's include bits standard C++ dot h. Now we have all the sets, map, multi-sets. Okay, so it is run for all the for the first test case. Let's try to run for all the test cases. So our code is passed for the all the test cases. So in the first, let's again, in the first, in this array, for in this for two for each loop, we are going to make a combination and adding that into map. Okay, adding that into map. If that combination is again occur, then we are increasing the count of that. After that, we are going to traverse over C and D array and finding the combination, and we are checking minus that k minus that combination into our map. If we have that combination, then we are adding the count of that combination, and if it's not, then we are saying that it is not present at that in the map, already not present in the map, and we are saying that it is 0. Okay, and returning from this point. So I hope you understand the question and the solution of this question. Thank you for watching.